Welcome to our little curious podcast, Hidden Synapses. What if one of the greatest discoveries in science was built on data taken without permission? Rosalind Franklin's X-ray images revealed DNA's double-helix structure, yet her name was buried in the footnotes of history. Today we uncover the true story behind the discovery of the code of life. Rosalind Franklin's story represents one of science's most significant oversights, where groundbreaking work met with undeserved obscurity. Her journey began in 1920 London, where she emerged as a scientific prodigy, supported by a father who recognized and nurtured her intellectual gifts. Despite the era's social constraints on women, Franklin pursued her passion at Cambridge's Newnham College, diving deep into chemistry and physics. Her father's background as a banker with a strong interest in education played a crucial role in supporting her unconventional path for that time. The Second World War provided an unexpected opportunity for Franklin to develop her expertise. Her work on coal and carbon research wasn't just a contribution to the war effort, it laid the groundwork for her mastery of X-ray crystallography, the technique that would later prove revolutionary in DNA research. After completing her PhD in 1945, she refined these skills in Paris, where she became renowned for bringing unprecedented clarity to the study of biological molecules through X-ray diffraction imaging. The pivotal chapter in Franklin's career unfolded at King's College London in 1951. Here she produced the famous Photo 51, a crystalline image of DNA that clearly revealed its double helix structure. This breakthrough should have cemented her place in scientific history. Instead, it became the center of a controversial tale of uncredited discovery, highlighting the challenges women faced in scientific fields during the mid-20th century. The story takes a troubling turn when Maurice Wilkins, her colleague at King's College, shared Photo 51 with James Watson and Francis Crick without her knowledge or consent. Using Franklin's meticulously gathered data, Watson and Crick constructed the first accurate DNA model in 1953. While their paper in Nature became legendary, Franklin's concurrent publication was relegated to a supporting role despite containing the crucial evidence that made their model possible. This oversight would have lasting implications for her legacy and recognition in the scientific community. Several factors contributed to Franklin's historical underrepresentation. The 1950s scientific community was deeply biased against women, with Franklin facing explicit discrimination at King's College. She couldn't even access the men's dining hall. The 1962 Nobel Prize in Physiology or Medicine went to Watson, Crick, and Wilkins, with no acknowledgement of Franklin's foundational contributions. Watson's later book, The Double Helix, further diminished her role through patronizing characterizations, though he would eventually admit to treating her unfairly in his portrayal. Franklin's scientific brilliance wasn't limited to DNA research. After leaving King's College, she made significant discoveries about virus structures, including groundbreaking work on the tobacco mosaic virus and polio. Her research continued to push boundaries and advance scientific understanding until her untimely death. Tragically, her life was cut short at 37 by ovarian cancer, likely caused by the very X-ray radiation that enabled her groundbreaking work throughout her career. Modern recognition of Franklin's contributions has grown significantly. Her name graces a crater on the moon. The Rosalind Franklin Institute in Oxfordshire continues her legacy in medical research, and the European Space Agency honored her by naming their Mars rover after her. Beyond her professional achievements, Franklin was known for her adventurous spirit, enjoying hiking and mountaineering, and for her direct, no-nonsense approach to scientific work. She maintained a sharp wit and insisted on the highest standards in her laboratory work. One of her most telling quotes reflects her holistic view of science. Science and everyday life cannot and should not be separated. This philosophy guided her meticulous work ethic and commitment to precision. Throughout her career, she demonstrated that scientific rigor and practical application could coexist, leading to breakthrough discoveries that continue to influence research today. Franklin's legacy serves as both an inspiration and a cautionary tale. Her work literally unlocked the code of life, yet she was nearly written out of history. While Watson and Crick became household names, Franklin's crucial role in one of science's greatest discoveries is only now receiving its due recognition. Her story reminds us that scientific progress often depends on unsung heroes whose contributions deserve to be remembered and celebrated, and serves as a powerful reminder of the importance of acknowledging and crediting all contributors to scientific advancement, regardless of gender or social status. History remembers Watson and Crick, but the double helix would have remained a mystery without Rosalind Franklin. Though she never saw the recognition she deserved, today her contributions are finally being acknowledged. This is the story of a scientist who saw the invisible and changed our understanding of life itself. Thank you for joining me on this journey through Rosalind Franklin's life. If you enjoyed this episode of our podcast, Hidden Synapses, don't forget to subscribe and share. And if there's another underrated scientist whose story you think should be told, let us know. We'd love to explore it in a future episode.